In section 7.3, we learn about logarithmic functions. In particular, we're going to learn how to evaluate elementary logarithmic expressions, evaluate the logarithmic expressions using a calculator, and how to graph those functions and recognize that some key features is vertical asymptote and which is where the input of the logarithm is equal to 0. Also, we're going to want to be able to translate between exponential equations and logarithm equations, because the truth is that exponentials and logs are basically the same the same relationship between the two values, the input and the output values. In the same way that multiplication and division sort of form what's called like a fact family. Like the fact that 4 times 5 equals 20 is the same relationship as 20 divided by 5 equals 4. It's just written kind of in a different way with a different operation. But those operations are very, very related to each other. And in general, if you say A times B equals C, the corresponding division fact is C divided by B is equal to A. Okay, so in this way, multiplication and division are inverse operations of each other. They undo each other. Like if you did 4 times 5 and then divide by 5, you get 4 back. In the same way, exponentials and logs are inverses of each other. And in fact, if you have this exponential equation written, say, 2 to the power 3 equals 8, that can be expressed equivalently by saying log base 2 of 8 equals 3. Here's sort of like the dictionary, how to convert between exponentials and logarithms. If you take the base number, raise it to the exponent, you get the answer. The logarithm says log base, whatever the base was, of the answer gives you the exponent. So the logarithm says base to what exponent power gives you the answer. So basically, the logarithm spits out the exponent in the expression, whereas the exponential spits out the answer. Okay, so let's get some practice converting between exponentials and logs. So here we have 7 to the power x equals z. The corresponding logarithmic fact family in this fact family would be log. The base would be 7, same as the base of the exponential. So log base 7 of z would be equal to the exponent, x. So these equations are equivalent. Okay, same thing here. Log base 2 of the square root of x equals y. So y is the exponent, the base is 2, square root of x is the answer. So let's rewrite this as an exponential. Base 2 to the power y should be equal to the answer, square root of x. Let's convert this one. Natural log of t minus 1 equals 6. So we have to know what ln means. So ln, what that means is log base e, where e is the exponential number. All right, let's just take a look on our calculator. E is a number in the same way that pi is a number. You see the number pi here? If you hit that on your calculator, it'll give you a decimal approximation, 3.141592654. In the same way, the letter E is a letter that we use to represent what's called the exponential number. So similarly to pi, the exponential number e is a decimal that has infinitely many digits after the decimal point and has nothing ever repeats. So it's approximately 2.71828. And it's used a lot in nature. So whenever we have log base e, you can just write it as ln, and that's logarithmus naturale in Latin. That's why it's ln instead of nl for natural log. Anyways, this really means log base e of t minus 1 equals 6. So if we wanted to convert that to an exponential equation, take the base e, raise it to the 6th power, set it equal to the answer. All right, last problem. Z equals e to the 5t. If we wanted to convert that to a logarithm equation, we'd say log. The base would be e. The answer is z. Set it equal to the exponent, 5t. Log base answer equals exponent. Great. And then the last thing you could do, actually log base e. That was that special natural log. So I could rewrite this as natural log of z equals 5t. So in this way, what we've just done is we've converted in between exponential equations and logarithm equations the same way you might convert a multiplication fact into a division fact. Right? All right, now we're going to use those ideas to solve equations involving logarithms. So here I have log base 8 of 1 equals x. So I could convert that to an exponential equation. 8 to the exponent power, x, equals the answer, which is 1. So when you are computing a logarithm, really you're playing the what's my exponent game. The base 8 to what power equals 1? Well, the only way you would get 1 out here is if the exponent was 0, right? Because anything to the 0 power is 1. So the solution to this equation would be x equals 0. All right, let's do the next problem. Log base 2 of 7x equals 2. This is written log base answer equals exponent. So I would convert that to base to the exponent power equals the answer. And now I can solve this equation. This is 4 equals 7x. Divide both sides by 7. 4/7 equals x. Let's do one more. Log base 128 of x equals 6/7. So this is log base answer equals exponent. So if I took the base, raise it to the 6/7 power, set it equal to x, set it equal to the answer. Okay, so that's a perfectly fine, this is the number, 128 to the power 6/7. I can get a decimal approximation. Oh, I get an exact number, 64. 64 equals x. All right, so in this way, again, I want you to think of logarithms and exponentials are basically the same concept. They form like a fact family. And whenever you see one of these equations, you can convert it to a logarithm equation by using this dictionary here and vice versa.